join on. You can see me. We'll pick up where we left off from yesterday. Okay. So yes, we were doing light chapter. We were on the last few parts of light. Correct. We'll start off from there. I'll be sharing my screen now. Hang on. Okay. Everybody can hear me. ಎಸ್ ನಿನ್ನೆ ನಾವು ಇದನ್ನ ನೋಡಿದ್ವಿ ಅಲ್ವಾ ದ ಡಿಫ್ರೆಂಟ್ ಬೇರೆ ಬೇರೆ ಪ್ಲೇಸಸ್ ನಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ ನ ಇಟ್ಟಾಗ ನನಗೆ ಯಾವ ರೀತಿ ಇಮೇಜಸ್ ಬಂತು ಅಂತ ನೋಡಿದ್ವಿ. ಅದಾದ್ಮೇಲೆ ಅದ್ರದ್ದು ಟೇಬಲ್ ಕೂಡ ವಿ ವೆಂಟ್ ಥ್ರೂ ಇಟ್ ಅ ಲಿಟಲ್ ಬಿಟ್. ಅದಾದ್ಮೇಲೆ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ನಲ್ಲಿ ಯಾವ ತರ ಇರುತ್ತೆ ಅಂತ ನೋಡಿದ್ವಿ. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ನ ಇನ್ಫಿನಿಟ್ ಅಲ್ಲಿ ಇಟ್ಟಾಗ ನನಗೆ ಹೇಗೆ ಪಾಯಿಂಟ್ ಆಬ್ಜೆಕ್ಟ್ ಬರುತ್ತೆ, ಆಮೇಲೆ ಮಿಕ್ಕಿದ್ದು ಬೇರೆ ಯಾವುದೇ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇಟ್ಟಾಗ ನನಗೆ ಹೇಗೆ ಬೇರೆ ತರ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಆಮೇಲೆ ಇದರಲ್ಲಿ ಯಾವಾಗ್ಲೂ ವರ್ಚುವಲ್ ಇಮೇಜ್ ಇರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ವಿ. ಕರೆಕ್ಟ್. So the same thing is given in this table as well. Okay, so the same thing we will pick up from where we left off. Sign conventions ಬಗ್ಗೆ ಕೂಡ ನಾವು ನೋಡಿದ್ವಿ. X axis ಮತ್ತೆ Y axis graph ನಲ್ಲಿ ನೀವು ಹೇಗೆ ಹಾಕ್ತೀರಾ, the same way like how you put in the graph, the same thing you are doing here, but instead of a graph sheet ಇಲ್ಲಿ ಮಿರರ್ ನ ನಾವು X axis ಅಂತ ತಗೊಂತೀವಿ, ಸಾರಿ ಮಿರರ್ ನ ನಾವು Y axis ಅಂತ ತಗೊಂತೀವಿ, ಆ ಪ್ರಿನ್ಸಿಪಲ್ ಆಕ್ಸಿಸ್ ನ X axis ಅಂತ ತಗೊಂತೀವಿ. Right, so these are the few things that you need to keep in mind. So ಇದಿಷ್ಟು ಆದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಬೇರೆ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು. Next I think we went through a few problems, right? We learned this, we revised this problem once, like how to find out what is the image distance and how to find out the height, making use of the magnification formula. ಇದನ್ನಲ್ಲೇ ಇವಾಗ ಒಂದು ಮೇಜರ್ ಪ್ರಾಬ್ಲಮ್ ನೋಡೋಣ. This formula is a combination of both image distance and finding the height of the image, and also we'll be focusing more on how the sign convention is used here. Okay, so take a look at this. An object 4 centimeter in size is placed at 25 centimeter in front of a concave mirror of focal length 15 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? So what kind of image are we looking for? We are looking to obtain a sharp image. Find the nature and the size of the image. So what is our agenda here? What is our goal here? To find the nature and the size of the image. ಆಮೇಲೆ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್, ಎಷ್ಟು ದೂರದಿಂದ ನಾವು ಸ್ಕ್ರೀನ್ ನ ಇಡಬೇಕು, ಸೊ ವಿ ಕ್ಯಾನ್ ಗೆಟ್ ಅ ಶಾರ್ಪ್ ಇಮೇಜ್. ಪ್ರಾಪರ್ ಇಮೇಜ್ ಬರೋ ತರ ನಾವು ಎಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡ್ಬೇಕು ಅದನ್ನ ಅಂತ ಕಂಡುಹಿಡಿತೀವಿ. ನಾವು ಸಿನ್ಸ್ ಆಬ್ಜೆಕ್ಟ್ ಇಸ್ ಆಲ್ವೇಸ್ ಪ್ಲೇಸ್ಡ್ ಅಬೌವ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಆಕ್ಸಿಸ್, ಹೈಟ್ ವಿಲ್ ಬಿ ಪಾಸಿಟಿವ್. ಕರೆಕ್ಟಾ? ವಿ ಆರ್ ಯೂಶುವಲಿ ಪ್ಲೇಸಿಂಗ್ ವೇರ್ ಆರ್ ವಿ ಪ್ಲೇಸಿಂಗ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಇನ್ ದ ಟಾಪ್ ಆಫ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಆಕ್ಸಿಸ್. ಕರೆಕ್ಟ್. ಸೊ ಅದಕ್ಕೆ ಏನಾಯ್ತು ಇವಾಗ, it is above principal axis, that is why height of the image is positive. H is equal to plus 4 centimeters. ನಮಗೆ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ಲಿ, an object 4 centimeter tall ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಲ್ವಾ. the same thing is what we are doing. 4 centimeter tall ಅಂದ್ರೆ 4 centimeter ಪಾಸಿಟಿವ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ. ಓಕೆ, ಯಾ Next, since the object is placed in front of the mirror, object distance is negative. We learned this right in the sign convention. Mirror ಈ ತರ ಇದ್ರೆ ಅದ್ರ ಲೆಫ್ಟ್ ಸೈಡ್ ಏನ್ ಇಟ್ಟಿರ್ತೀವಿ ನಾವು, ಅದ್ರ ಲೆಫ್ಟ್ ಸೈಡ್ ಏನೇನೆಲ್ಲ ಇಟ್ಕೊಂಡು ಹೋಗ್ತೀವಿ ಅದು ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ನನಗೆ ನೆಗೆಟಿವ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಬಿಕಾಸ್ from left to right, as I'm moving in this direction, it is becoming negative to positive. The same sign convention which I'm following on a number line, I am following it here. Okay. Next, I have focus of a concave mirror is in front of the mirror. This I know, right? Mirror mundene focus irutte in a concave mirror. So that is why what is happening to the focal length? The focal length is becoming negative, because then if this is the mirror and this is the reflecting edge, this is the non-reflecting edge where I'm drawing lines. Reflecting edge ಮುಂದ್ಗಡೆ ತಾನೆ ನಮಗೆ focus ಸಿಗೋದು. So ಏನಾಯ್ತು, since focus is in the opposite direction of incidence like this, so that is why I'm getting minus f. So now we understood, right, what is what?
Yes, sir.
Next, what we need to do is we need to find the image distance. We need to find a distance at which the screen should be placed to get a sharp image. So what is this magic distance where I need to place it to get a sharp image? That we will see how to calculate. So this distance is nothing but the image distance. So how do we find the image distance? We'll consider it to be v. What is the object distance? It is u. And what is the focal length? That is f. So what do I have here? I have a mirror formula saying 1 by f is equal to 1 by v plus 1 by u. I will use this to get the image distance. How do I use this? I just have to shift this 1 by u to the other side. 1 by u na ಆ ಕಡೆಗೆ ಹಾಕಿದಾಗ ನನಗೆ ಸಿಗೋದು 1 by f is minus 1 by u is equal to 1 by v. ಇದನ್ನ ಈ ಫಾರ್ಮುಲಾನ ನಾನು ಯೂಸ್ ಮಾಡ್ಕೊಂತಿದ್ದೀನಿ. So far everybody is clear? ಅರ್ಥ ಆಗಿರೋರೆಲ್ಲ thumbs up ಕೊಡಿ ಒಂದು ನಂಗೆ ಬೇಗ. Do it quickly. Okay. Great. So I'll just clear out the drawings and let's move on to the next part. So 1 by f is equal to 1 by v is equal to 1 by f minus 1 by u ಅಂತ ಫಾರ್ಮುಲಾನ ನಾವು ಬರ್ಕೊಡ್ತೀವಿ. Now start substituting. What do we substitute? We start substituting stuff that we know from the question. One is minus 50 and minus 25. Correct? Focal length ಏನು 15 centimeters, so it is minus 15 and object distance ಎಷ್ಟು minus 25. ಇದೆರಡು ನಾನು ಇಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. I am replacing that letters. Replace ಮಾಡ್ಬಿಟ್ಟು I'll start solving it step by step like this and I'll get a value for v. One thing I need to keep in mind here is 1 by v ಇರೋದ್ರಿಂದ ನಾನು v by 1 ಅಂತ ಮಾಡ್ಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ನಾನು v by 1 ಅಂತ ಮಾಡಿ. So v by 1 ಮಾಡಿದಾಗ ಇಲ್ಲಿರೋ ಈ ಕಡೆ ಇರೋ ವ್ಯಾಲ್ಯೂ ಕೂಡ ರೆಸಿಪ್ರೋಕಲ್ ಆಗುತ್ತೆ. So I'll be getting minus 75 by 2. That is nothing but 37.5 centimeters. So everybody is clear so far, right? So after all this is done, you need to write a conclusion. What is that conclusion? Screen should be placed at a distance of 37.5 centimeters. Correct. And negative sign means, what is this negative sign indicating? This negative sign is indicating that it should be placed in front of the mirror. Because according to the sign convention, negative sign ಯಾವ ಕಡೆ ಬರುತ್ತೆ ನನಗೆ? Everything between this here to here is negative. Correct. So ಇಲ್ಲಿ minus ಬಂದಿರೋದ್ರಿಂದ I'll say that the image formed is in this direction. Okay. Since image is in front of the mirror, image is real. Image real ಏನಕ್ಕಾಗಿದೆ? ಯಾಕಂದ್ರೆ image front of the mirror ಆಗಿದೆ. Which means that you are not extending the lines back to obtain an imaginary image. The image is real. That is why you can obtain it on the screen. Okay. So there you go. We found out what is the nature of the image. We found out what is the distance and where exactly it should be placed. These are the things that I can understand from just this one particular thing. Now how to find the size of the image? Size of the image andre height anta gottalla nimge. So height of the image nanu h anta tagondi. So what is the thing that I know? Magnification of a mirror is nothing but image distance by object distance. That is nothing but v by u. Also magnification of a mirror is height of the object by height of the image. Adanna nanu h dash h anta tagondidini. In your textbooks they might have taken it as h0 by hi ಅಷ್ಟೇ. Okay, h0 is nothing but the object height, hi is nothing but the image height ಅಷ್ಟೇ, simple. Okay, so now using this formula I will find out what is the height of the image, what is the size of the image. So how do I go about doing that? I'll start off here. I can say that minus v by u, since both of them are an equation for like formula for magnification. I will do this. What am I doing here? I'm just equating what the formula for both magnification is. One is minus v by u, one is h by h, h0 by hi or h dash by h. And now I will start substituting. What will I substitute? In place of minus v, I will put minus 75 by 2 because that is the value of minus v. In place of u, I'll put minus 25. Substitution from question ಅಲ್ಲೇ ಕೊಟ್ಟಿದ್ದಾರೆ ಇದೇನು ಅಂತ. h dash ನ ಹಂಗೆ ಬಿಟ್ಟಿರ್ತೀನಿ, ಆಮೇಲೆ h ನ 4 ಅಂತ ಬರೀತೀನಿ. ಮತ್ತೆ ಏನಾಗಿದೆ ಕ್ವಶನ್ ಅಲ್ಲೇ ಇದನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಇದಿಷ್ಟು ನಾನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ ಐ ಸ್ಟಾರ್ಟ್ ಸಾಲ್ವಿಂಗ್ ಫಾರ್ h dash. h dash ಗೆ ಸಾಲ್ವ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡಬೇಕು? ಫಸ್ಟ್ ಮೈನಸ್ಗಳನ್ನೆಲ್ಲ ಒಳಗಡೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೋಬೇಕು. ಮೈನಸ್ ಇಂಟು ಮೈನಸ್ ಏನಾಯ್ತು? ಪ್ಲಸ್ ಆಯ್ತು. ಇಲ್ಲಿ ಕೆಳಗಡೆ ಇನ್ನೊಂದು ಮೈನಸ್ ಇರೋದ್ರಿಂದ ಮೈನಸ್ ಪ್ಲಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಮೈನಸ್ ಅಂತ ಆಯ್ತು. ಸೊ ಈ ಇಡೀ ಪಾರ್ಟ್ಗೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಒಂದು ಅಂಟ್ಕೊಂಡಿದೆ. ಓಕೆ, ಸೊ ಸಿನ್ಸ್ ದಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್ ಏನಾಯ್ತು ಇವಾಗ? ಸೊ ಡೈರೆಕ್ಟ್ ಆಗಿ ನನಗೆ minus 75 by 2 whole divided by 25 ಅಂತ. Now I will shift 4 to the other side. ಸೊ ಏನಾಯ್ತು? 4 ನ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿದಾಗ ಇಂಟು 4 ಆಯ್ತು. ಇಂಟು 4 ಅಂದ್ರೆ ಮೀನಿಂಗ್ ಏನು? ಇಟ್ ಮೀನ್ಸ್ ದಟ್ ಐ ಕ್ಯಾನ್ ಕ್ಯಾನ್ಸಲ್ ಔಟ್ ದಿಸ್. 2 1s are 2, 2 2s are 4. ಓಕೆ, ಸೊ ಅದು ಎಲ್ಲಿ ಬಂದು ಕೂತ್ಕೊಂತಿದೆ ನನಗೆ? ಇಲ್ಲಿ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಬಂದು ಕೂತ್ಕೊಂತಿದೆ. ಹ್ಯಾಂಗ್ ಆನ್ ಅ ಸೆಕೆಂಡ್. ಯಾ, ಅದು ಎಲ್ಲಿ ಬಂದು ಕೂತ್ಕೊಂತಿದೆ ನನಗೆ? ನ್ಯೂಮರೇಟರ್ ನಲ್ಲಿ ಕೂತ್ಕೊಂತಿದೆ. ಸೊ ದಟ್ ಈಸ್ ವಾಟ್ ಐ ಆಮ್ ಗೆಟಿಂಗ್ ಹಿಯರ್. 2 1s are 2 2s are. ಸೊ ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ನನಗೆ ಸಿಗೋದು minus 6 centimeters. ಐ ಆಮ್ ಜಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಅಂಡ್ ಸಾಲ್ವಿಂಗ್. ಇದನ್ನ ನೀವು ಪ್ರಾಪರ್ ಆಗಿ ಕಲ್ತ್ಕೋಬೇಕು. ಎಲ್ಲೆಲ್ಲಿ ಏನನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋದು ಅನ್ನೋದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಓಕೆನಾ? ಎಲ್ಲರಿಗೂ ಕ್ಲಿಯರ್ ಆಯ್ತಾ? ಸೊ ಯಾ, ಹೋಪ್ ಎವ್ರಿಬಡಿ ಅಂಡರ್ಸ್ಟುಡ್. ಗಿವ್ ಮಿ ಅ ಥಮ್ಸ್ ಅಪ್ ಆಸ್ ಸೂನ್ ಆಸ್ ಯು ಸ್ಟಾರ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಸ್ಟಫ್. ಥಮ್ಸ್ ಅಪ್ ಕೊಡಿ ಎಲ್ಲರೂ, ಬೇಗ ಬೇಗ ಬೇಗ. ಕಮ್ ಆನ್ ಫಾಸ್ಟ್. ವೆರಿ ಗುಡ್. Yes. And also turn on your video so that I know who is seeing and who is not seeing. Okay, anyways, we'll move on to the next one. Next, size of the image 6 centimeter anta gottaytu nanage. Size of the object 4 centimeter anta gottaytu. What is the difference between the two of them? 4 centimeter gina 6 centimeter doddadalva. So that is why I can say that the image is enlarged. And then I also have minus sign with the image. So that is why I can say that the image is inverted. Therefore, what is the nature of the image now? It is inverted and enlarged. ಓಕೆನಾ? ಸಿ, ನಮಗ್ ಬರೋ ಆನ್ಸರ್ ನಲ್ಲಿ ಯಾವ ಸೈನ್ ಇದೆ, ಆಬ್ಜೆಕ್ಟ್ ಜೊತೆಗೆ ಹೇಗೆ ಕಂಪೇರ್ ಆಗ್ತಿದೆ, ಇದನ್ನೆಲ್ಲ ಇಟ್ಕೊಂಡು ನಾನು ಇಮೇಜ್ ನೇಚರ್ ಬಗ್ಗೆ ಮಾತಾಡಬಹುದು. ಸೊ ಕೀಪ್ ದಿಸ್ ಇನ್ ಮೈಂಡ್. ಹೋಪ್ ದಿಸ್ ಇಸ್ ಕ್ಲಿಯರ್. ವಿಲ್ ಮೂವ್ ಆನ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕ್, ದಟ್ ಇಸ್ ರಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್. ಇಷ್ಟೊತ್ತು ನಾವು ನೋಡಿದ್ದು ರಿಫ್ಲೆಕ್ಷನ್. ವಾಟ್ ಇಸ್ ರಿಫ್ಲೆಕ್ಷನ್ ಟೆಲ್ಲಿಂಗ್ ಮೀ? It is telling me that when I throw a ball like this, it is hitting the wall and it is bouncing back. But the same thing is happening with light. Light ಹಿಂಗೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಸರ್ಫೇಸ್, ಪ್ಲೇನ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಇನ್ಸಿಡೆಂಟ್ ಆದಾಗ ಅದು ಹೀಗೆ ರಿಫ್ಲೆಕ್ಟ್ ಆಗುತ್ತೆ, ಕರೆಕ್ಟ್ ಅಲ್ವಾ? ಬಟ್ ಅದೇ ರಿಫ್ರಾಕ್ಷನ್ ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ? ಇಟ್ ಯೂಶಲಿ ಹ್ಯಾಪನ್ಸ್ when I am transferring light from one medium through a transparent medium. Bending of light is called as refraction of light. Okay, what of light is called as refraction of light? Bending of light. Okay, so what exactly can I observe when I say bending of light? Let me take the example of a glass slab. ಇದನ್ನಲ್ಲಿ ಕೇಳ್ತಾರೆ, ಯಾವ್ದ್ರಲ್ಲಿ ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ಕೇಳ್ತಾರೆ, ಲೈಕ್ ಇದನ್ನ ಡ್ರಾ ಮಾಡ್ಬಿಟ್ಟು ಇದನ್ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋದು, ಸಮಥಿಂಗ್ ಲೈಕ್ ದಟ್ ದೇ ವಿಲ್ ಆಸ್ಕ್ ಯು. ಸೊ ಲಿಸನ್ ಟು ದಿಸ್ ವೆರಿ ಕೇರ್ಫುಲಿ. ಎಲ್ಲೆಲ್ಲಿ ಏನೇನಾಗುತ್ತೆ ಅಂತ ಹೇಳ್ತೀನಿ. ಸೊ ಯು ಆರ್ ಫಸ್ಟ್ ಟೇಕಿಂಗ್ ಅಪ್ ಅ ಗ್ಲಾಸ್ ಸ್ಲಾಬ್. ದಿಸ್ ಇಸ್ PQSR is your glass slab, and outside you have air. So outside medium is called as a rarer medium. I'll take its refractive index as 1. Inside medium is a denser medium. I'll take it as N2. Okay, N1 and N2. So when light travels from one medium to another medium, light bends depending upon whether it is a rarer medium or a denser medium. So this kind of refraction, this kind of bending of light, this kind of property of light which is showing bending when it travels from one medium to another medium is called as refraction. What is this called? Refraction. That is exactly what my red lines is showing. See, look at it. The line EO is starting from air, right? It is coming and it is falling on this particular glass slab here. So when it falls like this, what is happening? It is bending. How is it bending? It is bending towards the normal. ಏನಾಗ್ತಿದೆ ಇಲ್ಲಿ ಅದು ನಾರ್ಮಲ್ ಕಡೆಗೆ ಬೆಂಡ್ ಆಗ್ತಿದೆ. So when air travels from a rarer medium, from where to where? Rarer medium to denser medium. Rarer medium ಇಂದ denser medium ಗೆ ಅದು travel ಮಾಡಿದಾಗ it is bending towards normal. Okay, it is bending towards normal. The same light, if it is traveling from denser medium to rarer medium, it is bending away from normal. That's ಇದನ್ನ ನಾಲ್ಕ ಇಟ್ಕೋಬೇಕು. You will be describing the same thing in your exam for this particular topic. Okay. Yes. So as it is moving through the glass slab, we can see that there is refraction happening two times. Once ಅದು enter ಆಗ್ಬೇಕಾದ್ರೆ ರಿಫ್ರಾಕ್ಟ್ ಆಗ್ತಿದೆ, ಮತ್ತೆ exit ಆಗ್ಬೇಕಾದ್ರೆ ಕೂಡ ರಿಫ್ರಾಕ್ಟ್ ಆಗ್ತಿದೆ. So this is happening because of the difference in the medium. Once it is going from rarer medium to denser medium, and again it is going from denser medium to rarer medium. Yes, hope this is clear for everyone. Now look at the original path of the light. ಏನಾಗಿದೆ ಒರಿಜಿನಲ್ ಪಾತ್ ಆಫ್ ದಿ ಲೈಟ್? ಅದು ಸ್ಟ್ರೈಟ್ ಆಗಿ ಹೋಗ್ಬೇಕಿತ್ತಲ್ವಾ? ಗ್ಲಾಸ್ ಇರೋದ್ರಿಂದ ಈ ತರ ಬೆಂಡ್ ಆಗಿದೆ, ಕರೆಕ್ಟ್? ಸೊ ಇಲ್ಲಿ ನನ್ಗೆ ಇಷ್ಟು ಡಿಫ್ರೆನ್ಸ್ ಇದೆ. So instead of me looking at the image here, I am looking at the image here. Now what is this phenomenon called? Does anybody know? If anybody knows the answer, put it in the chat box quickly. I'm looking at the chat box. Let me see who will answer fast. Come on. Ready, set, go. Yes, I'll give you 10 seconds time. So think in that time and you put it here. 10, 9, 8. What is the distance between the original path of the light and the emergent ray called as? You know this, right? Illi, I'll just point out using a laser pointer. This light which is falling on the glass slab is incident, right? This is the refracted ray, and the one that is coming out after that is the emergent, correct? And this is the original path of light. The change between the original path of light and the emerged ray is called as what? What is it called as? That is the question. So what is this distance called as? Red null mark ಮಾಡಿದನಲ್ಲ, double arrow mark use ಮಾಡ್ಕೊಂಡು, what is that distance called as? Put it in the chat box if you know the answer quickly. Yes. Okay, refractive index anta ondast answer bantu. Refractive distance. Can you repeat the question, sir? Okay, that I repeated, right? Okay. So everybody agrees that it is refractive index. So this particular distance is called as, hang on a second. Lateral displacement. Side ಹೋಗ್ತಿದೆ ಅಲ್ವಾ, ಇಲ್ಲಿ ಇರಬೇಕಾಗಿರೋ ಇಮೇಜ್ ಸೈಡ್ ಹೋಗ್ತಿದೆ. So it is called as lateral displacement. Understood? So this is lateral displacement. So everybody is clear on the glass slab experiment. The things that you need to note down here is, you're talking about the glass slab, you're talking about the incident ray, and you're talking about how the incident ray is bending towards here. Okay, and this is called as a refracted ray, and this is called as the emergent ray. The ray which comes out of the glass slab is the emergent ray. Okay, and there are two different refractive indices here. One is for air, one is for glass. Air gene bere refractive index irutte, glass gene bere refractive index irutte, because of how close the atoms are. Okay, so everybody, I hope everybody understood this concept of refraction and how refraction is happening in this particular what do you say, glass lab experiment. This is what you're supposed to explain in your exam. Write it in scientific technical terms only, otherwise you'll not get marks. Next, there are two laws of refraction. Reflection ge hege ಎರಡು law ಇತ್ತು, refraction ಕೂಡ ಅದೇ ತರನೇ ಎರಡು law ಇದೆ. The first one is very similar to what you have studied in law of reflection. The incident ray, the refracted ray and the normal at the point of incidence lie in the same time. ಒಂದೇ plane ನಲ್ಲೇ ಇರುತ್ತೆ. ಯಾವುದು incident ray, refracted ray and the normal at the point of incidence remain in the same plane. Okay, ಇದು clear ಆಯ್ತಾ ಎಲ್ಲರಿಗೂ? Next, second one is called as Snell's law of refraction. So this Snell's law is telling me that sine of angle of refraction divided by sine of angle of incidence will give me refractive index. Correct? Sine of angle of refraction and sine of angle of incidence will give me, the ratio between these two will give me something called as refractive index. It is denoted by the term mu. What is that symbol called as? It is denoted by the term mu. Yeah? Did everybody understand? Everybody give me a thumbs up quickly. Do it fast. Okay. So let's move in. So now this refractive index is based upon the speed of the medium. Okay, ನನ್ನ medium the speed ಹೇಗಿರುತ್ತೆ ಅದ್ರ basis ಮೇಲೆ ನಾನು refractive index ಅನ್ನು ನೋಡ್ತಾ ಇದ್ದೀನಿ. ಅದನ್ನಲ್ಲಿ ನಾನು ಎರಡು ತರ ನೋಡಬಹುದು. So this one you don't have to focus too much on this. I'm just telling it you in view of revision. Okay, N21 ಅಂತ ಕೇಳಿದ್ರೆ ಅವರು speed of light in medium 1 to speed of light in medium 2. N12 ಅಂತ ಹೇಳಿದ್ರೆ speed of light in medium 2 to speed of light in medium 1. Okay, 1:2, 2:2, something like that. Okay, that is refractive index and how it is related to speed of light. Next we'll be talking about lens, and there's something called as absolute refractive index. This absolute refractive index means speed of light in vacuum to speed of light in medium. ಇದೊಂದು ಜ್ಞಾಪಕ ಇಟ್ಕೋಬೇಕಾಗುತ್ತೆ. Next, lens. There are two types of lenses. One is convex lens and one is concave lens. Mirror ನಲ್ಲಿ ಹೇಗೆ concave mirror converging mirror ಆಗಿತ್ತು, lens ನಲ್ಲಿ ಅದೇ ತರನೇ convex lens is the converging lens. Okay, so what is the difference between mirror and a lens? In the mirror, light is falling and reflecting back, but in a lens it is traveling through the lens and going outside. The image is always formed in the opposite side of where the light is incidenting, because these lenses are made up of two different spherical mirrors. Two spherical mirrors ನಾನು ತಗೊಂಡು ಈ ತರ ಅಟ್ಯಾಚ್ ಮಾಡಿದಾಗ ನಂಗೆ ಏನ್ ಸಿಗುತ್ತಲ್ವಾ ಅದನ್ನೇ ನಾನು ಲೆನ್ಸ್ ಅಂತ ಕರಿತೀನಿ. That is what is shown here. So in convex lens we call it as converging lens, and concave lens it is diverging lens. Let us see the different cases of the convex and concave lens. Image na ಬೇರೆ ಬೇರೆ ಕಡೆ ಇಟ್ಟಾಗ ನಂಗೆ ಯಾವ ರೀತಿ object na ಬೇರೆ ಬೇರೆ ಕಡೆ ಇಟ್ಟಾಗ ನಂಗೆ ಯಾವ ರೀತಿ images ಸಿಗುತ್ತೆ ಅಂತ ನೋಡೋಣ. Okay, again same whatever criteria are there, everything will be same. Only difference being here ನಿಮಗೆ ಮಿರರ್ ನಲ್ಲಿ C1 ಅಂತ ಮಾತ್ರ ಸೆಲೆಕ್ಟ್, ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್ ಒಂದೇ ಇತ್ತು, ಬಟ್ ಇಲ್ಲಿ ಎರಡು ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್ ಇದೆ because you have two different mirrors. So you are calling it C1 and C2, and there will be two different foci, that is one is F1 and one is F2, and then the center of curvature has another name, twice the focal length, twice the focus, 2F5 ಆಮೇಲೆ 2F1 ಮತ್ತೆ 2F2, and then whatever is there no here O, that is your pole. Okay, ಮಿರರ್ ನಲ್ಲಿ ಪೋಲ್ ಇರೋ ತರಾನೇ ಇದರಲ್ಲಿ ನಮಗೆ O ಇದೆ ಮಧ್ಯದಲ್ಲಿ. Okay, so now what is happening here? So look at the first case, the object is kept at infinity, so all the rays are coming taken parallel to the principal axis. Same ಮಿರರ್ ನಲ್ಲಿ ಹೇಗೆ ಅದು ರಿಫ್ಲೆಕ್ಟ್ ಆಗಿ ಫೋಕಸ್ ಮೇಲೆ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ತಿತ್ತು, ಇಲ್ಲಿ it is passing through the lens, and because of the bending all the light rays are bending and converging at the focus, that is the focus that is on the other side of the incidence. Okay, ಅಷ್ಟೇ ಸಿಂಪಲ್. ಯಾವ ಕಡೆಯಿಂದ ಲೈಟ್ ಬೀಳ್ತಿರುತ್ತೆ ಅದ್ರ ಆಪೋಸಿಟ್ ಸೈಡ್ ನಲ್ಲಿ ನಮಗೆ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಅದ್ರ ಆಪೋಸಿಟ್ ಸೈಡ್ ನಲ್ಲಿ ನಮಗೆ ಅದೇನೇನು ಕನ್ವೆನ್ಷನಲ್ ಮೆಥಡ್ಸ್ ಇದೆಯೋ ಆ ಕನ್ವೆನ್ಷನಲ್ ಮೆಥಡ್ಸ್ ಆಗುತ್ತೆ. So that is the first case. It is all converging at focus, and as you can see it's a point object. We'll discuss the nature of the image in the next slide. Next, second type ನೋಡಿ, it is beyond 2f ಅಂದ್ರೆ ಏನು, it is beyond the center of curvature. Correct. What is happening? I'm again taking two things. One is the light passing through the pole or the origin, and the other one is parallel to the principal axis. So what is happening to the line parallel to the principal axis? It is passing through the pole. Correct? See, it is going like this and passing through the focus here. Yes. And what is happening to this one? It is just going directly like this. It's passing through, it's going in a straight line. So this is clear for everyone, right? Now, where is the image formed? It is coinciding here, and the image is formed inverted here. This is for the case beyond 2f. And if the object is placed at f, then what is happening? Again, I'll take the same two lines. One is through the center, one is parallel to it, one is parallel to the principal axis, and finally it is going through the focus and it is connecting over here at a dash. So what is happening here? Again, I'm getting an inverted image. So this is how I'm getting the images are formed in a convex lens like this. And images in the convex lens is formed due to refraction. Refraction ಆಗ್ತಿರೋದ್ರಿಂದ ನನಗೆ image form ಆಗ್ತಿದೆ ಇಲ್ಲಿ. Next ಇನ್ನೊಂದು ಕೇಸ್ ನೋಡೋಣ ಅಂತೆ. Object between f and 2f. f ಮತ್ತೆ 2f ಮಧ್ಯೆ ಇರೋದ್ರಿಂದ ಆಬ್ಜೆಕ್ಟ್ ಯಾವ ರೀತಿ ಕಾಣಿಸುತ್ತೆ ನನಗೆ? ನಾ ತರ ಇಟ್ಟಾಗ ಮತ್ತೆ ಸೇಮ್ ಅದೇ ಟೂ ಲೈನ್ಸ್ ನ ತಗೊಂತೀನಿ. ಯಾವ್ದಾದ್ರು ಟೂ ಲೈನ್ಸ್? ಒಂದು ಪ್ಯಾರಲಲ್ ಟು ದ ಪ್ರಿನ್ಸಿಪಲ್ ಆಕ್ಸಿಸ್, ಒಂದು ಥ್ರೂ ದ ಒರಿಜಿನ್. ಸೊ ಈ ತರ ಪ್ಯಾರಲಲ್ ಟು ದ ಪ್ರಿನ್ಸಿಪಲ್ ಆಕ್ಸಿಸ್ ಹೋಗೋದು ಫೋಕಸ್ ಒಳಗಡೆಯಿಂದ ಹೋಗುತ್ತೆ. ಇಟ್ ವಿಲ್ ಟಚ್ ದ ಒರಿಜಿನ್ ಅಟ್ ಸಮ್ ಪಾಯಿಂಟ್ ಬಿಯಾಂಡ್ ದ ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್, ದಟ್ ಈಸ್ C2. ಸೊ ಅಲ್ಲಿ ನನಗೆ ಇಮೇಜ್ ಸಿಗುತ್ತೆ ಈ ತರ, an enlarged image. Yeah, we'll discuss the nature of the image in the next slide. And then I have, if the object is kept exactly at focus, image will be formed at infinity. Right? You can see, right? If it is parallel like this, it is just going on and on and on and on. Again, same thing if it is passing through the origin. So it is formed at infinity. If the object distance is kept between the focus and the origin, means it is smaller than the focus object distance. Avag enaಗ್ತಿದೆ? Same thing will happen. I'll get it at infinity. Where am I getting it at? I'm getting it at infinity. But when I drag back the dotted lines, when I trace back the original path of the line, I will get a virtual image formed on the same side of the mirror. This is the only case in the convex lens where I'm getting it in the same side of the mirror. Okay, as you can see, convex lens ಯಾವ್ದಕ್ಕೆ ಸಿಮಿಲರ್ ಆಗಿದೆ? ಕಾನ್ಕೇವ್ ಮಿರರ್ ಗೆ ಸಿಮಿಲರ್ ಆಗಿದೆ. ಕರೆಕ್ಟಾ? ಸೊ ಇದೇ ತರ ನನಗೆ ಇನ್ ಲೆನ್ಸಸ್ ಕಾನ್ಕೇವ್ ಲೆನ್ಸ್ ಏನಿದೆಯಲ್ಲ ಅದು ನನಗೆ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ಜೊತೆಗೆ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. ರೈಟ್, ಐ ಹ್ಯಾವ್ ಓನ್ಲಿ 2 ಕೇಸಸ್. ಅಲ್ಲಿ ನನಗೆ ಏನಿತ್ತು, ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ಗೆ ನನಗೆ 2 ಕೇಸಸ್ ಮಾತ್ರ ಇತ್ತು. ಸೊ ಹಿಯರ್ ಐ ಹ್ಯಾವ್ 2 ಕೇಸಸ್ ಫಾರ್ ಕಾನ್ಕೇವ್ ಲೆನ್ಸ್. So the position object, if it is at infinity, the image is formed at the focus, that is virtual, erect and highly diminished image. The same thing if it is between infinity and the origin, then I have virtual, erect and diminished image, but not as bad as the first case. This is for concave lens, and yeah, this is for the convex lens. What is happening at infinity? So the image is real and image inverted, but it is highly diminished and point sized. And beyond 2f1, we discussed, right? The image is diminished again. And at 2f1, it is formed at 2f1, it is the same size. Between f1 and f2, it is enlarged. And again, if it is at the focus, it is found at infinity. So it is infinitely enlarged or highly enlarged. Between focus and origin, that is the optical center, that is the image is enlarged when compared to the object. So this is about the two different lenses. Lens kuda on formula ide, same to same. Whatever you're doing for the mirror, the same thing you're doing for lens. The only difference is the way you take the signs. Okay, it is given here in this table here. You can make a note of this, or you can make a note of this. So 1 by f is equal to 1 by u plus 1 by v anta ide alla. Alli u bandu object distance, v is the image distance. Correct. So for convex lens, focus, object distance and the principal axis is always positive. For a concave lens, this is always like focus and image distance, and principal axis is always negative. Okay, everybody is clear with this particular part? So this is the formula that you need to remember, and sign convention will be very similar to that, but adel place agide anta nodkoಬೇಕಾಗುತ್ತೆ. Okay, and from where the light is falling, image object distance mele everything is based upon here. And then again, magnification is same, size of image by size of object. So, and then here in lens, you will get one more thing called as power. So that is given as nothing but it is the degree of convergence of divergence of a light rays. So lens has the ability to converge or diverge, right? The degree through which it can converge or diverge is called as power, and power is equal to 1 by f, and f is always taken in meters. F ನ ನಿಮಗೆ ಸೆಂಟಿಮೀಟರ್ಸ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದೆ, ದಯವಿಟ್ಟು ಅದನ್ನ meters ಕನ್ವರ್ಟ್ ಮಾಡಿ ಆಮೇಲೆ 1 by f ಮಾಡಿ, so that you can get power. Also the unit of power is diopter. It is given by capital D. It is given by what? It is given by capital D, like this. Okay, so I'll discuss one of the statement. I'll discuss one of the problems. Define power of the lens. What is its SI unit? Define power of the lens. What is its SI unit? One student uses of lens of focal length 50 centimeters, another of -50. What is the nature of lens and its power used by each of them? Power, and then just now we studied the definition. Write the same definition. SI unit of power is diopter when focal length is measured in meters. That is why they always take focal length as meters only. So now let us look at the two cases. Focal length 50 centimeter ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, focal length -50 ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ. So keep this problem in mind. ಇದನ್ನ ನಾವು ನಿಮಗೆ ಫೈನಲ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲೂ ಬರ್ಬೋದು. ಪವರ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದಕ್ಕೆ 1 by focal length ಮಾಡಬೇಕು. So 50 centimeter is nothing but half meter. Use that, you will get the type of power. 2 diopter -2 diopter. If it is positive, it is convex lens. If it is negative, it is concave lens. And then yeah, some last minute tips for you guys to ace your exams. So answer to the point always. Know the difference between